Hello, my name is Kim Soo-il and I'm a professor at Daegu University. I have thought about how to improve the freshness of agricultural products, how to boost their export, and how to build the infrastructure for the packaging industry with the goal of developing policies that can invigorate the agricultural packaging industry. This is a matter of how packaging skills should be applied to achieve the goals that I just mentioned. So Korea's experience will help Cambodia to establish policies that best suit the country's environment and circumstances. Unlike industrial products, agricultural products maintain their vital activities such as respiration even after being harvested. After harvest, agricultural products have no choice but to consume the nutrients they have accumulated because they no longer have any external supply of nutrients, which will consequently damage their freshness and commercial value. The consumption of nutrients caused by respiration, weight reduction resulting from evaporation due to transpiration, and ripening caused by continuous metabolic activities deteriorate the quality of farm products. Among them, the most fundamental reaction is respiration. In the storage temperature of a crop by 10 degrees, its respiration rate goes down by 2 to 3 times, while its freshness increases by 2 to 3 times. Therefore, crops should be frozen after harvest to slow down their respiration. Such as a process is called pre-cooling. Pre-cooling can limit the loss of nutrients caused by respiration, the weight reduction due to evaporation, and the ripening resulting from metabolism. The agricultural products that are distributed at a low temperature are sold at higher prices as their quality can be better maintained. Different agricultural products have different psychological characteristics, so pre-cooling, low-temperature storage, and low-temperature distribution should be carried out in consideration of their unique properties to avoid chilling injury. A cold chain system equipped with a pre-cooling system, refrigerated trucks, and a refrigerated sales system should be in place to facilitate low-temperature distribution. That requires a tremendous social cost. Some large supermarkets have invested a huge amount of money to build their cold chain system. Agricultural products, if distributed at a high temperature, suffer weight loss and wilting due to transpiration caused by respiration. Corrugated cardboard boxes, plastic films, can be used to block the influence of outside temperature or the contact with outside air in order to prevent evaporation. The hardness of a corrugated cardboard box may be reduced as it absorbs moisture if severe transpiration occurs. Ventilation holes can be made on the sides of the box to prevent this problem. Yet, a comprehensive judgment is required since the compression strength of the box can be compromised while making the holes during the manufacturing process. Plastic packaging may cause severe dew condensation inside. This makes the fruits or vegetables inside the packaging contact with the water drops and allow germs and molds to multiply, accelerating the decomposition of the products. If crops are not divided into small packages, just like in traditional markets, the crops will be exposed to the outside air, lose their moisture, and eventually suffer weight reduction or wilting. A way to prevent this is to cover the products on the shelf with wet newspaper or to spray water directly onto them. You can keep them from wilting by supplying moisture. The metabolic activities of fruits and vegetables generate ethylene gas, which promotes ripening. Ethylene gas accumulated in the packaging accelerates the respiration of fruits and vegetables, dramatically reducing their freshness. The oxygen permeability rate of the film itself can be improved to release the ethylene gas inside the packaging and increase the freshness. Ethylene gas absorber can be put in a sealed envelope and used to absorb the gas accumulated with the packaging directly. Another way is to mix ethylene gas absorber into the packaging film to absorb the gas being generated within the packaging. To develop ethylene absorbing film, absorption materials should first be identified, and the methods for mixing the materials into the film and the mixing ratio for each product should be studied to build a database. In Korea and Japan, ethylene absorbing films are merely being used to store farm products in refrigerators at home because it is difficult to use films that absorb ethylene gas for products on the shelves of department stores or large supermarkets. The first reason why this type of film is not being used by large supermarkets is because of its materials. It is easy to apply functional packaging materials to LDPE materials, but they cannot be applied to OPP materials. That is the biggest reason. Second, these materials reduce the transparency of packaging. Minerals such as zeolites should be fine ground and mixed into the film to absorb ethylene gas, and the presence of these minerals inevitably lowers the transparency of the film. However, consumers are more familiar with the ordinary transparency of OPP films, so those films with a lower transparency will be less preferred in the market. Third, the cost is higher. A master batch process is a must before mixing the functional materials into the film. The cost associated with the process increases the unit price of the film. MA packaging is another way to extend the freshness of farm products. When crops are packed in packaging materials whose oxygen permeability is controlled, the oxygen density inside the packaging drops while the CO2 concentration increases, naturally slowing down the crop's respiration rate. MA packaging utilizes this phenomenon. This is necessary to make a database of oxygen permeability per product so that microventilation holes can be made on films to suppress respiration, in consideration of each product's respiration characteristics, distribution temperature, and packaging units. Laser punching and pins can be used to control oxygen permeability. The laser machine can control the intensity of laser or the irradiation area of laser that is applied on the film surface. The pin technique controls the depth of pin penetration in consideration of the film's thickness in order to control the area based on the required oxygen permeability rate. Water evaporation can be enhanced if the strength of penetration is not appropriately controlled and the film gets torn, so it is crucial to control the strength to control oxygen permeability while preventing water leakage. Experiments on the oxygen permeability rate should be carried out for each product based on its respiration rate. Repetitive experiments should take place for verification before using the technique in the field to prevent trial and error. Mushrooms, sprouts, salad ingredients, broccoli, and other agricultural products that quickly lose their freshness tend to have higher respiration rate, so both low temperature distribution and MA packaging are required for these products. The installation of microventilation holes may increase the packaging cost by 20 to 30%. An automatic package machine for sealed packaging incurs a fixed cost of KRW 35 million. CA storage stands for Controlled Atmosphere Storage. This method improves the storability of fruits and vegetables. This is a storage technique that suppresses the respiration of crops during storage by artificially controlling the gas concentration. There are an injector and an ejector that control the density of oxygen, carbon dioxide, and nitrogen to create an environment where respiration within the chamber can be suppressed. The storage warehouse should use finishing materials that have a high insolution capacity to minimize any temperature change caused by changes in the outside temperature. Apples, pears, grapes are suitable for CA storage. The CA storage technique is used along with an ethylene gas removal unit to extend the freshness of farm products. The storage period can be extended by suppressing the generation of ethylene gas and thus inhibiting metabolism and ripening. The application of 1 MCP materials prior to harvest helps the extension of freshness by suppressing the generation of ethylene gas during storage. Far infrared radiation or weak radiation activates biological activities and consequently improves storability. Freshness can be improved by using ceramic mixed packaging materials. Post-harvest management technique is critical to maintain the quality of agricultural products harvested from farms until they are supplied to consumers, increasing their added value. Consumers' demand for the quality and safety of agricultural products continues to increase. Consumers are particularly sensitive about the freshness, taste, smell, and color of farm products. Consumers choose what to buy based on these properties. Post-harvest management technique is a must for having a competitive edge in the area of opening up where our agricultural products should compete with foreign crops at home and abroad. Countries that are advanced in agriculture recognized the importance of this technique a long time ago. They have carried out academic research on the technique and used it widely in the agricultural and industrial fields. In Korea, the Ministry of Agriculture provided the budget to develop a manual book for 36 crops between 2006 and 2008. The representatives of the Korean Society for Horticultural Science and the Producer Distribution Department of National Agriculture Cooperative Federation authored the book. The manual book provides summarized information about 6 processes along with a schematic diagram of post-harvest management. The book provides the background, objectives, and overview, the scope, the status of R&D in and outside of Korea, the level of Korea's technological achievement for the items that require research and development. I hope that Cambodia will be able to develop its own manual book by referring to Korea's manual book for post-harvest management techniques. I will use the manual book for post-harvest management of tangerines as an example. Tangerines originated from China and Southeast Asia are largely divided into tangerines and mandarins. There are many different varieties of tangerine. Citrus satsumas, Mediterranean mandarin, king mandarin, common mandarins are varieties of tangerine that are well known globally. C. reticulata and similar varieties have a high share in the U.S. market. Most of the tangerines produced in Korea are citrus satsumas, which is commonly called satsuma mandarin. Post-harvest physiology. Respiration type. Tangerine is a non-climacteric fruit that does not show ripening-related respiration and an increase in ethylene. The amount of ethylene generated at 20 degrees is normally less than 0.1 ULKG1HR1. The respiration rate at the optimal storage temperature is below 10 mg CO2 Kg1HR1. Changes during ripening. The diameter-length ratio of satsuma mandarin increases during ripening. The ABA and acid contents are higher in the fruit's core than in the fruit skin, but the soluble solid content is higher in the fruit skin than in the fruit core. The flavonoid content in the fruit skin peaks during the early ripening stage and then drops. Maturity level and grading standards. Maturity level is determined when sugar-acid ratio is the lowest and when at least 50% of the color of fruit skin is changed. Transpiration. External factors such as humidity and temperature affect the rate of transpiration. Internal factors such as tangerine variety and the presence of injury also change the transpiration rate. Moisture loss takes place quickly when the relative humidity is low. It takes place gradually when the relative humidity is high. If moisture is condensed on the surface, it affects the spread of germs as well. Fruit waxing can reduce moisture loss and improve the fruit skin's resistance against transpiration, which will consequently prevent weight loss and maintain freshness. Coloration. Coloration of tangerine is mainly done for tangerines of early maturing varieties. Ethylene is commonly used for coloration. Tangerines are colored through ethylene treatment at a temperature of 28 to 29 degrees, relative humidity of 95%, and concentration of 1 to 5 UL 1 to 1 for 3 days, 12 hours per day. Components. High-quality tangerines are oval-shaped and have a hard and thick orange and red colored skin. The fruit should not be any defect, and it should be easy to separate the skin from the flesh. The edible part of the fruit should be succulent and seedless. A tangerine contains 2.4 to 7.8 grams per 100 millimeter of sucrose, which takes up the highest portion among all sugar components. The content of fructose and glucose is approximately 1 to 1.5 grams per 100 millimeters. Among the carotenoids components in the tangerine skin, phylaxanthin accounts for the largest proportion, followed by cryptoxanthin, luteoxanthin, anthraxanthin, phytoene, and zeaxanthin. Changes in the fresh weight, decay rate, total soluble sugars, acidity, and vitamin C content during storage do not have a significant impact on the fruit size. Ethylene treatment significantly reduces chlorophyll. Kinetin and BA can partially offset this phenomenon. Gibberellin also shows some effect. Changes in components after harvest. Beta-carotene and cryptoxanthin, the main pigments of the tangerine skin, exhibit orange color. Chrysanthemaxanthin makes greenish-yellow color, and lutein and anthraxanthin shows green-orange color. The average content of carotenoid in the skin and flesh of 14 varieties of Korean tangerines is 1.5 mg% and 7 mg% respectively. The skin color of Satsuma mandarin is attributable to the low N content in its skin and in the increased sugar content. The total pectin content in the tangerine skin is 0.94%. Pre-harvest treatment. Adding 0.01 to 0.05% propionic acid promotes ripening and ethylene generation. CaCl2 treatment prior to harvest does not have any impact on the reduction of fresh weight, but it is somewhat effective in controlling the decay rate and maintaining hardness. Spraying calcium promotes the coloration of Satsuma mandarins, increases the A value of the fruit skin, and prevents decaying, improving their commercial value. Pre-storage treatment. Temperature treatment before storage is effective in limiting the fresh weight loss and respiration of Satsuma mandarins during storage. Satsuma mandarins are pre-dried because they are vulnerable to extremely high relative humidity. Satsuma mandarins are pre-dried so that they can lose 3 to 5% of their weight before storage. It is reported that chilling injury during storage can be reduced by pre-drying fruits for 3 days at 35 degrees before storing them at 2.5 degrees. The natural weight loss during storage after harvest is minimal when the fruits are pre-dried at 25 degrees and lost 5% of their weight prior to storage. Weight loss due to decaying is minimal when the fruits are pre-dried at 20 degrees and lost 3% of their weight before storage. Intermittent pre-drying minimizes any loss in color, hardness, sugars, organic acid, vitamin C, and flavor components, which determine the quality of the tangerine. Intermittent warming is effective in maintaining the tangerine's appearance and flavor. Heat treatment is related with improving the fruit's low temperature tolerance during low temperature storage. Hot water dipping or dipping at 52 degrees is known to be effective. Keto acid and calcium treatment can significantly reduce the decay rate and weight loss of halabong tangerines compared to non-treated products. It is known that keto-CAT is a major antioxidant enzyme that is related with the defense mechanism against low-temperature stress. When injured Satsuma tangerines are stored, their decay rate is 63.5%. 20.7% of the decay is attributable to Penicillium italicum, followed by Penicillium digitatum, Alternaria citri, Geotrichum candidum, Diaporth citri, and Phoma citricarpa. Keto acid treatment can reduce storage diseases. Keto acid will be absorbed into fruit skin cells and exhibit a double effect. Treatment with 100 ppm benzoladinin reduces the decay and respiration rates and slow down the ripening of tangerines. TPZ can also reduce the decay rate significantly. Sorting. Sorting is divided into weight sorting and quality sorting. Sorting machines are used for weight sorting, but quality sorting is done by visual inspection. So it is difficult to sort the fruits into many grades and to standardize the grading standards in an objective manner. This is why non-destructive sorters that look at the sugar content of fruits are recently being introduced in the industry. Color, shape, defects, and other factors that determine the quality of fruits are examined during the sorting process. Damage caused by rough handling, vibration damage resulting from inappropriate sorting, physiological and pathological damages caused by the poor environment of packaging container may be observed. Distribution. The post-harvest management and transportation from distribution center processing include automatic packaging, cleaning, and transportation to markets. Tangerines are moved by large trucks, ships, aircrafts from their production sites to consumption sites. Inappropriate management during the process results in quality degradation. Low temperature storage. Tangerines can maintain a good quality for 8 to 12 weeks at a temperature of 5 to 8 degrees and a relative humidity of 95%. Chilling injury occurs when the temperature is below 5 degrees. Their storage period depends on their variety, maturity level, and whether decomposition is controlled or not. Their shelf life is greatly influenced by their initial quality, physiological damage, storage disease, and sugar acid ratio. TBZ, when used together with fruit coating materials, is effective in suppressing decomposition during storage. MA storage. Moisture loss and storage disease can be reduced by coating tangerines with edible keto acid and by using MA storage technique. MA wax coating reduces chilling injury and is effective in maintaining hardness. The commercial value and quality of tangerines can be maximized by treating them at 3 to 4 degrees at a 20 degrees along with wax coating. The combination of wax coating and intermittent warming and treatment at 4 to 5 degrees using polyethylene bag and KMNO4 are helpful to maintain their freshness. CA storage. CA treatment is more effective than low temperature storage if you are planning to store satsuma mandarins for 3 to 4 months. Physiological damage. Tangerines are thin-skinned and are thus easily damaged when stored at a high relative humidity. Therefore, if you use machines to sort, clean, and pack tangerines, the tissues in the outer layer of their skin will be damaged and their flesh tissues will be destroyed. Oleocelosis occurs on the fruit skin when excessive force is applied to harvest fruits by hand. The higher the turgor pressure of fruit skin, the bigger the damage. Puffiness is a phenomenon where the fruit flesh is separated from the fruit skin during transpiration and storage. Puffiness is mainly observed in tangerines, mostly in overripe tangerines. Stem and rind breakdown involves water-soaked, irregular lesions near the stem or the collapse of tissues. It is closely associated with excessive moisture loss and is commonly observed in late maturing fruits. Chilling injury appears as pits on the fruit skin. The occurrence of chilling injury increases as the duration of storage at below 5 degrees rises. Tangerines exhibit dried sections. Their sensitivity is chilling injury is largely affected by their variety and the level of ripening. Pathological damage. Stem end rot is an important issue when it comes to tangerines. It is commonly observed in early maturing varieties that have been inserted. Stem end rot invisibly infects the stem area before harvest and spreads toward the core of the fruit after harvest. Anthracnose is a major disease of tangerines caused by Cholotachrocum glosporiates. Anthracnose exhibits brown lesions. It occurs when the coloration process is prolonged. Tangerines are affected with brown rot at groves before being harvested. The disease causes unpleasant odors and spreads to the whole fruit when it meets an appropriate environment. Tangerines are infected with green-blue mold through the damages made during the harvesting and sorting process. By soaking tangerines in a TBZ solution before they arrive at the sorting site, you can prevent Diplomedia, Phomopsis, anthracnose, and penicillium. Blight can be prevented by coating tangerines with imazalil or TBZ. Stem and rot infection that is attributable to Diplomedia and anthracnose can be minimized by delaying harvest and subsequently reducing the duration of coloration. Brown rot can be effectively controlled if you treat tangerines with disinfectants containing copper before harvest. Careful handling of fruits at sorting sites can reduce the damage caused by putrefactive germs such as penicillium. Regular disinfections of equipment and storage facilities at packaging centers can minimize pathological damages. Blight. In Florida, U.S., carbine fruit flies appear at groves in late spring and summer. Fruits are treated at a low temperature to control the blight caused by these fruit flies. Fruit fly infection can be limited by treating fruits at a temperature of 2.2 degrees or less. However, considering their sensitivity to chilling injury, fruits are first stored at 10 to 15 degrees for about a week before low temperature treatment. We are using containers to export our agricultural products. 20 feet and 40 feet containers are commonly used. Fresh farm products are placed in refrigeration containers for export. The maximum load weight of a container is 20 tons. In many cases, there are limitations on the load volume rather than on load weight. Transportation cost takes up a substantial part of the total cost of export. So boxes should be designed in a way that can maximize the load efficiency of containers to minimize container fees. DW corrugated cardboard boxes are being used to maintain the minimum strength that can prevent pressure damage during the export process. BA corrugation is widely used to manufacture DW corrugated sheets. If this is shifted to BB corrugation, the load efficiency can be improved in many cases. When BA is used, the box thickness will be 8 mm. However, if you use BB, the thickness of box can be reduced by 2 mm to 6 mm, and the length and the width can drop by 4 mm each. So there will be more space available in the container. Therefore, the use of BB should be considered positively. Seaborne export involves longer transportation period compared to airborne export. Waves and other factors can increase the moisture content within the container, significantly reducing the compression strength of cardboard boxes. If the ship is rolled due to waves, cardboard boxes will become wet and weaker. They can eventually collapse. To prevent this, you should use corrugated cardboard boxes that meet the requirements for compression strength. The base papers used to manufacture corrugated cardboard sheets can be divided into kraft liners that are 100% kraft pulps and jute liners made from recycled papers. The waterproofing capacity of kraft liner is much greater than that of jute liner. Therefore, you should always choose kraft liners whenever it is possible for outer and inner lining when you're deciding the materials of corrugated cardboard boxes to be used for export. If you are using jute liners, your corrugated cardboard boxes should be designed to have a compression strength that can offset any reduction in strength that may appear as the base papers absorb moisture. You should use base papers that have a great water repellent capacity to address the issues associated with moisture absorption. Water repellent agents are applied after coating the base papers with water-soluble wax and drying them. It is also not advisable to simply apply strong hydrophobic coating because excessive coating may cause sliding during loading. It is better to use materials that have a higher compression strength in the corrugating medium rather than in a liner broad. Boxes that will be placed in a refrigeration container should have a smooth flow of cold air to prevent any issues associated with temperature rise. Ventilation holes should be made on the sides or on the front back of the box. The surface area of these ventilation holes determines their ventilation capacity. When making ventilation holes of the same area on a corrugated cardboard box, The holes should be designed in a manner that can minimize the damage to corrugation and prevent claims on compression damage. The closer the holes are to the center of the box, the more the compression strength will be reduced. When you're making ventilation holes on products that weigh 10 kilograms or more, you should note that the holes will also be functioning as handles. You should use materials that are strong enough so that liner-based papers will not be torn and cause a problem in the product packaging. It is better to locate the holes near the edges. A pallet can either be used or not used to load fruits into a container. If you use a pallet, loading and unloading will become easy, but your transportation cost may go up because the number of boxes that can be loaded into a container will be limited. If you don't use a pallet, you will be able to load more boxes into the container, but it will take more time to load and unload them. When using a pallet, you should check the standards for pallet dimensions of the importing country and use a pallet that meets the standards. By doing so, you can use the racks in the importing country for unloading and storage. This should be checked in advance, since if your pallet is off the standards, you won't be able to use the racks installed at the warehouse in the importing country. Loading methods should also be reviewed in consideration of the flow of cold air. An airway is needed to ensure a smooth flow of cold air. Everything should be fixed properly so that loaded boxes will not collapse due to the airway. Bulge effects of boxes will occur after loading many boxes into the container, so you should have some extra space available between the boxes in addition to the calculated space requirement. It will be practical to add 5 mm as an extra space to the horizontal and longitudinal dimensions of the box when you calculate the number of boxes that will be loaded. You should also add 5 mm to the horizontal and longitudinal dimensions of the box when you're planning how to load your boxes into a pallet to have some leeway. This is a great tip because if you don't have these extra spaces, some part of your boxes will be placed over the edges of the pallet and their compression strength will be compromised. You must have many concerns about how you can boost the export of Cambodian agricultural products through policy making. Korea has strived to find a breakthrough that can expand the export of our agricultural products by strengthening its R&D capacity. Our efforts have shown some great success. In that context, I would like to introduce the functions, responsibilities, and workflows of the Research Group on Agriculture Export, which was established in 2008. I hope that our experience will help you to develop effective policies that can expand the export of Cambodian agricultural products. Current status. The Research Group on Agriculture Export analyzed the potential damage that our agricultural sector and farms would suffer if the Korean-US FTA came into effect and planned a new R&D project as a countermeasure for such damage. The Ministry of Agriculture always tried to analyze the potential damage to Korea's agricultural industry and to come up with measures to compensate for such damage every time when the Korean government accelerated its opening up drive. However, this research group is meaningful in that it aims to develop aggressive measures with the goal of dominating the tables around the world with our agricultural products. Project scope. The Research Group on Agriculture Export supported the development of strategic technologies for export to discover promising agricultural products that can appeal to international markets and develop these products into globally recognized farm products. The ultimate goal of this project is to foster agriculture as a competitive export industry. The Ministry of Agriculture was determined to achieve its target of USD 5.5 billion in the export of agricultural products by 2017 in line with the mid- and long-term comprehensive plan for agriculture export, and to achieve at least USD 2.5 billion in the export of strategic items through R&D activities. The plans was to identify and develop 5 or more agricultural products with the goals of exporting at least USD 100 million worth of these products and of exporting USD 1 billion or more of our products to the US market. The goal was equivalent to increasing the trade volume of our agricultural products by an average of about 8.7% per year for the next 10 years. This way, a very ambitious goal considering that the export growth rate of Korean agricultural products had remained at 3% for the previous 10 years, and that the Korean Rural Economic Institute had estimated export growth rate by 2017 as 3.5% to 4.8%. The Ministry of Agriculture decided to foster and stimulate the export of high value added seeds and varieties by carrying out strategic projects on the development of superior varieties. The strategy was to utilize the world's best breeding technology to nurture the seed industry as a high value added, leading export industry to pay the royalties for horticultural varieties and to respond to the opening up of the import market. To develop innovative technologies, products tailor-made for export, technologies can be satisfy the demands for the food culture, preference, and quality from the consumers of the importing countries should be developed and the foundation for entering the niche market should be laid. It was also decided to improve, homogenize, and standardize product quality and to develop eco-friendly farming techniques and eco-friendly materials. The development of techniques for post-harvest management, slaughter management and processing, as well as the industrialization of cutting-edge technologies required for producing health-functional agricultural products and convenient processed foods that have a high added value had to be reinforced. To address difficulties associated with export and innovative our distribution structure, the export distribution structure was innovated and dynamized and networks were facilitated. The techniques for maintaining quality and freshness during storage, packaging, and transportation were developed to promote export. This was a 10-year project which was carried out from 2008 to 2017. The project had long-term and short-term goals. Its primary objective in phase 1 was to expand the technological foundation for agricultural export and to secure complementary technologies. The objective of Phase 2 was to secure strategic technologies for export for the penetration into foreign markets. This was the workflow. The Item Selection Council established at the Ministry of Agriculture selected promising items to be exported. A public offering was issued for the research group on agriculture export project by item. A consortium was formed with organizations responsible for export planning, R&D, production, export, and marketing of the item concerned. Candidate groups submitted their project plan, and the plan was evaluated by experts under the leadership of the Agricultural R&D Promotion Center. The Minister of Agriculture selected one group per item. Items were selected. A consortium was formed with different organizations that deal with export planning, R&D, agricultural production, export, and marketing. And the representative organization prepared a project plan and submitted it to ARPC. Once the final project group was selected, a strategic export planning committee was formed to review the group's project plan and establish more detailed plan for the project. The committee involved experts of the selected item, representatives of the project group and the Ministry of Agriculture, and experts of the ARPC. Increased export of agricultural products can not only contribute to country's wealth, but also reduce the volume of farm products in the domestic market. This means that the price of agricultural products will be maintained at a certain level, stabilizing the incomes of producers and stimulating the rural economy. It will also serve as a momentum to take the country's agriculture techniques to the next level, since world-class skills are required to produce high-quality products that can be exported. As high-quality, eco-friendly, and safe farm products become a norm, the reputation of our agricultural products in overseas markets will be significantly improved, boosting the volume of their export further. The introduction of eco-friendly farming will reduce the damage and contamination caused by pesticide and heavy metal residues and prevent animal disease, so social costs arising from these problems will be reduced. New energy will be brought to the agricultural sector, and more advanced, innovative, and high value-added models of farming will be presented. agriculture will show its potential to become a new growth engine of the country. Food is the most primitive form of commodities that is essential for humans to sustain their life. The food industry is bigger than the automobile or electronic industry and is showing the rapid growth. The food industry was worth USD 7 trillion in 2016 and USD 8.2 trillion in 2020. It is expected to reach USD 9.2 trillion by 2023. The food industry has limitless potential and is drawing attention as a new engine of growth for the future, as it can be associated with advanced technologies and evolve into a high-value added industry. Packaging plays essential roles in improving price and sales competitiveness because it affects how well the product is protected as well as the promotion, convenience, logistics, and eco-friendliness of the product. Without packaging, foods will merely remain as something to eat. They will not have any commercial value or function. Packaging also plays important roles in maintaining the quality of most foods for longer to have the upper hand in the market. Packaging is a critical factor in the food industry, and food and beverage account for more than 50% of the packaging industry. This shows how big the market is. The global packaging market was worth USD 760 billion in 2018. Food packaging accounted for half of the market. Food and beverage packaging took up 69% of the market. Korea opened the Food Packaging Center at the Korean National Food Cluster in February 2022 to build the infrastructure for our food packaging industry and further develop the industry, which is the most important part of the whole packaging industry. I will introduce the roles of the center so that you can use it as a reference in establishing the infrastructure for the agricultural packaging industry in Cambodia. Let's watch a short video. The mission of Food Palace is to serve as the hub of the Northeast Asian food market. To achieve this mission, the Food Packaging Center is providing high-level packaging techniques to the food business residing in Food Palace. To aim to become the representative organization of Korea that will drive the R&D and promotion of food packaging in the mid and long term. Our ultimate goal is to benchmark relevant research institutions at home and abroad and bring the industry, the academia and public sector and research organizations together to build a model of independent research institution that can be recognized globally. The roles and functions of the Food Packaging Center can be largely divided into 4 areas. First, it supports business residing in Food Palace with more functional and safer food packaging technologies so that they can thrive as food companies that can appeal to global market. Second, it provides packaging-related assistance to promote the food industry of Korea. Functional and eco-friendly packaging technologies that can dramatically improve the shelf life and freshness of food will be required for Korea to be competitive in the global food market. Third, R&D on food packaging technologies. Through R&D, the center supports the business residing in Food Palace with differentiated technologies. R&D is necessary for Food Palace to become a world-renowned organization specialized in food packaging in the mid and long term. Fourth, technological exchange and human resources development. One of the reasons why Koreans' food packaging technology falls behind those of more advanced economies is that the country does not have enough experts in that field. Therefore, a system should be in place to facilitate local and international networking and to foster human resources. The 6 main goals of the Food Packaging Center are as follows. Consultation and technological guidance. Business residing in Food Polis can visit the Food Packaging Center and receive consultation when they face difficulties related with packaging. When necessary, the Food Packaging Center will visit the resident business concerned to provide on-site technological guidance. Design and R&D. Unlike daily supplies or electronic products, the shelf life of processed food is not very long. Therefore, the center develops packages for new products upon request from companies and also carries out R&D projects to reinforce its own capacity and to develop future technologies. Analysis, testing, and evaluation. A wide variety of packaging tests take place in the packaging laboratory of the center upon request from resident companies and for R&D purposes. Food manufacturers can request the center to carry out packaging tests to examine if their packaging materials are valid or to meet the demand from their vendors. The center issues a report for each packaging test. Assistance with packaging design. Food packaging design can accentuate the product and offer a differentiated image of the product, which may motivate consumers to buy it. So companies residing in food policies can receive assistance with their visual design and container design development. Training and information provision. Business residing in food policies can receive technical education on packaging and related information. Based on its mid-long-term training plan, the center provides all resident companies with complementary training. As for additional technical training, which will be provided with it is demanded by the industry, the companies will be partially charged for the training to promote their participation and to let them recognize the need for such training. International exchange. Major developed countries have research institutions specialized in food packaging, and they have been engaged in active exchange. World-recognized food packaging organizations maintain strong ties with related institutions and business across the world to spread their advanced skills and to further improve their country's food packaging techniques. The center will also strive to build strong relations with these organizations to strengthen Korea's food packaging techniques and to lay the strong foundation to become independent. We've discussed how we can stimulate the agricultural packaging industry based on Korea's experience in this area. I hope that my lecture will help you to develop solutions that will work best for Cambodia. Thank you.